Hello guys, welcome back to my YouTube channel. Today I am going to solve day 3 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today we are going to solve problem number 79, word search, and this problem is asked in Amazon, Intuit, in Google. So mark this question as important, and this problem is a classic example of backtracking. Okay, so this problem it's easy actually. So by the end of this video, you guys will be able to understand the code and everything. But just focus on the code while writing, because while writing I am also going to explain side by side. Okay, so just focus while writing the code as well. Okay, so now let's read the problem statement. So in this problem we have given an m by n grid of characters board and a string word, and we have to return the true if the word exists in the grid, and the word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Okay, and these are the three examples given to us, and these are the constant. So m is equal to board dot length, n is equal to board of I dot length, and m and n value is ranging between 1 to 6, and word dot length is ranging from 1 to 15, and word consists of only lowercase and uppercase English letters. Okay, so now let's understand the problem with an example here. Okay, so this is a word given to us. Okay, and we have to search for this word. Okay, so this is a one grid given to us. Okay, rows and columns. So in total, how many columns are there? Columns length is 4 and rows length is 3 right now, right? So we are going to start searching from our this position. So this is nothing but 0 by 0. Okay, 0 row 0 column. Okay, so if I am going to do index, so it will be looking like this: 0 1 2. This is 0 1 2 3. Okay, so now first of all I'm going to check for this 0 by 0 index. I'm going to start from this position, and I'm going to check if my first character is matching with the first character of my word. Okay, if this element 0 of 0 is matching with my first character of my word. Okay, so in this case it is matching. Okay, so I'm going to start. Once I check this, I'm going to start for the I'm going to start searching for the next word. Okay, so from here I'm going to use call one method. Okay, and that method is going to check all the letters, right side, left side, up side, and row and down side. Okay, so once I find that my first character is matching with this index, after that I'm going to call one method, and that method is going to give me value either true or false. Okay, so that method is going to check whether this word is there in my board or not. Okay, so what's going to happen once this is true? Okay, I have found this word, then after that I'm going to search in my left, in my right. Okay, in my right, up, left, and down. I'm going to search for everything one by one. Okay, so first of all, let's say that I move to my left. Okay, I move to my left. So side by side I'm going to mark this as visited. Okay, this is visited. So in circle means that I have visited this. Okay, after that, once I reach B, I go to my right, so I mark this as visited. Okay, after that, I let's say that I move to this position. Okay, I mark this visited, but now I see that this word is not matching with the next word. Okay, I need A B C C E. Okay, but this is nothing but C here, and I'm getting here E. So I need to mark this as unvisited, and I need to go back. Okay, so now after that my C is going to search for so let's say my C goes down. Okay, my C goes down. So now my C reaches at this position. Okay, I mark it as visited. Okay, now after that again my C is going to move to down. Okay, and again my E is going to check for all the possibilities. So if it's found, if it reaches at this particular position, and then it is going to mark this as visited. And if in case, if this becomes, okay, if this A B C C E D, okay, if I am going to take care of one index, okay, there is going to be one index in which I am going to increment the values if I found the matching values one by one. So if any case my index matches with this word dot length, then in that case I have to return true. Okay, in that case I have to return true if my index matches with word dot length. Okay, same way here I am going to start from searching from this position. If my word is matching with this first word, no, then after that I am going to move forward. Okay, I reach at this position, I reach at this position, I reach at this position, then I'm going to start from this position. Okay, so now this is matching with this S. Okay, if this is matching, then after that I'm going to search for all the paths. I'm going to go for search in the right, I'm going to search for in the up, I'm going to search for the down. Okay, if I don't find that character, the next character that I am looking for, then I have to return false. If I return false, then after that I move forward, I move forward. Okay, and then I reach at this particular position. Okay, so once I reach at this particular position, so yes, I have found that this character is matching with my first character, so I mark this as visited. Okay, I mark this visited. Then after that I'm going to search for all the sides. So first let's say I go down. Okay, or let's say I go up. Okay, first say I go up. Okay, I mark this as visited. So this is also matching now, so I mark this visited. Then after that I check all the possibilities. I go left, out of bound, I go up, out of bound, I go here, see, oh no, I don't need this. Okay, so I come back, I mark this E as unvisited, I mark this S as unvisited. Now after that I'm going to check for the other possibilities. Okay, so right now if I move for here in the left side, again I'm not looking for C. Okay, so I have to again come back again. If I reach at this position, out of bound, then after that I came at this position. Okay, so when I come at this particular position, so this is matching. Okay, this word is matching, so right now I mark this as visited. Then from here I'm going to check all the possibilities. I'm going to go right, I can't move up. Okay, because this is already visited. I can't visit one node two times. Okay, I can't visit one index two times. Okay, so after that I reach at this particular position. So at this particular position I see my index length is becomes 3, and I'm already incrementing the index count when I found that a node is visited. Okay, so now when my index becomes 3 and my word C also becomes 3, then in that case I have to return true. Okay, now same way in the third example, just this first character is matching, so I mark this visited. Then again I search for right, I go right, this is matching. Again I go right, this is matching. Okay, now after that from C, I am going to check all the possibilities because I need B right now, right? So let's say I go to my right. Okay, this is not matching, so I came back. Okay, I come back. So from C I go up. Okay, out of bound. Then after that from C I go down. Okay, this is not matching with B. Can I go to this position? No, because we can't visit already visited node. Okay, that is why I am marking it as visited. So I can't go like this, A to B, B to C, and then C to B. Okay, this is wrong. So right now we don't find any word, okay, which is matching in this board. Okay, this word matching in the board. Okay, so we didn't find. Okay, so in this particular case we are returning false. Okay, so now I am going to write the code, but while writing the code, please focus, because now only you guys will get much clear idea what I'm saying, right? Okay, so first of all, uh, let's do one thing. Okay, if my board is null, actually we don't need to write this condition, but still, if my board is null, okay, if my board is null, or if my board dot length is equal to, if my board dot length, these are the base cases actually, if board dot length is equal to 0, and if my word is null, if my word is equal to null, or my word dot length is equal to 0, then in that case we have to just return false, right? We have to just return false. Okay, then after that I'm going to need my rows height and my column height. Okay, so int m, so let's check for the number of rows. Okay, so m is equal to board dot length. Okay, this is done. Then n is going to give me the columns. Okay, so int n, let's select any board. Okay, let's pick first board, first row, and let's calculate the length. It will give me my columns length, right? This is done. Then after that I have to write for loop. Okay, for int I is equal to 0, I is less than m, I plus plus. So here I am going to go over each board, okay, row and column wise. So I have to write two loops, right? One is for rows and one is for columns, right? J is less than m, j plus plus. Okay, I is rows, okay, I is m and j is less than n. Then after that, if I am also checking, right, if the character, okay, if the word at this particular index, at the particular index board of I of j is matching with the my word first character, right? Only in that case I have to move further, otherwise I don't need to search, right? Word dot char at 0, if it is matching, then after that and operation, now search for the next word. Okay, so for that I'm calling using this DFS method. Okay, in this DFS method I am passing my board, I am passing the word, okay, I am passing the row index, I am passing the column index, and I am going to pass the length, okay, the length what I found till now. So this is nothing but my index. Okay, this is my row index, column index, and this is the index. Okay, in this I am going to count the number of words that I have found. If this becomes equal to my word dot length, then in that case I have to just return true. Okay, and this is going to visit it. Okay, so this is going to keep track whether I visit that element or not. Okay, so here this is done. Okay, but I haven't defined this visited yet, so write this visit as well. Okay, boolean array, boolean visited is equal to new boolean okay. So in this way I'm going to mark the elements as visited if I visit any of them, right? This is done. So here after this if condition I have to just return true. If this gives me true, okay, this method gives me true, just return true because we have already found the word. And if we are not able to find that word, then in that case just return false, return false. Okay, so I hope that this is clear. Okay, I hope that this simple code is clear till now. Okay, now after that I'm going to define this method DFS. Okay, so here private boolean DFS method, and in this DFS method I am passing my board, my string word. So let me copy this. Okay, these two things are that I am passing here. Okay, this is done. And then I am going to pass my row index, my column index, and one particular index which is going to keep track the number of words that I found, and one boolean visited array, right? Boolean visited. Okay, so I hope that this is clear now. Now I'm going to write the code inside this. Okay, so now inside this, if my index becomes this word dot length, then in that case I have to return true, right? Okay, bird dot length, then in that case I have to just return true. Okay, this is done. Now after that I have to check. These are some base conditions. If my index I value is less than 0, okay, or if my j goes out of bound, j is less than 0, or if my I is greater than equal to board dot length, okay, or if my j is greater than equal to board of 0 dot length. Okay, base conditions only. Okay, or if I have already visited that particular element. Okay, if I have already visited that particular element I and j, if I have already visited this, okay, and or if board of I of j is not equal to bird dot char at index. Okay, okay, if my I is greater than is less than 0 or my j is less than 0, if my I is greater than board dot length or my j is greater than equal to board 0 or dot length, or visited of I j is already visited, okay, or board of I j is not equal to bird dot char at index. If any of this condition is true, then in that case I have to return false. Okay, return false. That means we didn't find the word. Okay, we didn't find the suitable part. Okay, this is done. Then otherwise, let's mark the mark our visited element as true. Visited of I, I of j is equal to true. Okay, this is done. Then after that we are going to check for all the elements. First we are, let's say first I go down. Okay, I go down first and then I go up. I'm going to check everything. Okay, then after that I'm going to move left and I'm going to right. Okay, so I'm going to check all the sides if I find any suitable path. Okay, after A I'm going to searching for the B. Okay, so I'm going to go down, I didn't find, I go to left, I found one path. Okay, so this is done. So here I'm going to write one if condition, and in this if condition I'm going to call for my DFS method, and inside this DFS method I'm going to pass this board bird I comma j visited. Okay, this, but right now first let's say I move up, let's say I move down. Okay, I plus 1 and j, then index is going to be index plus 1. Okay, that means that I have already found one index. Okay, that's why I am incrementing index plus 1 and this is visited. Okay, okay, now again I move up, now I move down. Okay, I move first, I move down, now I move up. I minus 1 j index plus 1 visited. Okay, this is done. Again, now let's move to the right side. I j plus 1 index plus 1 and visited. And now let's move to the left side. Okay, I j minus 1. Okay, so this is done. So now if I found any suitable path, then I am going to just return true. Return true. Okay, now after this if I don't find any suitable path, so I have to keep the backtrack, right? So for that purpose I have to mark the already visited node as false. Okay, if I don't find any suitable path, then I just need to mark this as false. Okay, and in the end I have to just return false. Okay, so now let's try to run the code and see. So all the test cases has been accepted. Now let me submit it. So our solution is accepted, right? So here see what we are doing. So initially I am checking if my board is equal to null, if my board dot length is equal to null, or my word is equal to null, or word dot length is equal to null. Then we are just returning false. After that I am checking for the rows length, columns length. Then I am going to use one boolean visited array. In this array I am going to keep track whether I already visited that index or not. Then after that I am running one loop. Okay, so this is one board given to us, so we are going to check row and column wise. Okay, so that is why two loops. So if the first character of my board is matching, if the first character of my board is matching with the first character of my word, then in that case we have to find one path. Okay, if it doesn't match, let's say if I am at this position S, then we don't need to search. Okay, we don't need to run check for this method because it will already become false. Okay, so if this is the case, then I'm going to call this method. Okay, so here I'm calling for this method. So initially my index is 0 only. Okay, I am at this particular position only. Okay, so if my index is equal to void dot length, so right now it is not, so we don't need to do anything. Then after that I am checking for the base condition. If any of this becomes true, then in that case we have to return false. And then I am going to mark this particular element as visited, and then I am going to look down, up, left, and right and left. Okay, and if I found any suitable path, then I'm going to return true. Okay, one by one, and otherwise I have to just keep backtrack. So I mark this particular element as false if I don't find a suitable path, and in the end I have to return false. Okay, so I hope that you guys are clear with today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.